Next is Alex Wood from Ansys. He's going to talk to us about, well, the title is To Earth and Beyond. Sounds like, isn't that what you yell before you jump off a tall building? To Earth and Beyond, high fidelity analysis and visualization using 3D tiles. All right, give him a hand.
Hi, everyone. I'm Alex Wood. Over there's Greg Beatty. And I'm here to actually tell a story about how open standards and 3D tiles really helped help us take our terrain usage to the next level. So next slide is my job right here. Real quick thing, so I'm here talking about how we use 3D tiles in Systems Tool Kit. Just in short, it's and it's been around for 35 years of modeling system of systems and interactions between those. And a couple of years ago, when we came together with the parent company Ansys, one thing that we got was access to a lot of high fidelity physics tools and solvers. And so we started pulling in and coming up with new ways to combine those. And RF Modeler is one of those. Traditionally, how that was used was in urban environments. And so from the start, we actually decided to have 3D tiles kind of the input data for visualization analysis in that RF Modeler product. And everything was great. And then it's JP, who's actually going to be following me in a couple talks here, came with a curveball on how we need to do some modeling on the poles on the moon. And I'm going to talk a little bit about why that's a difficult problem. So cesium globe, and we see here this is a TMS tiling scheme. And this is what we're typically used to seeing our terrain binned in, where you have got these nice latitude, longitude grids that bin the tiles, but when you wrap that around the globe and zoom in on a pole, you'll see how that all pinches together at the poles. And that poses a problem for visualization, also analysis, because you end up with tons and tons of just individual meshes that you have to pull and do analysis on, and it's just not efficient. So polar data is actually in polar stereographic projection, and it's in a nice, you see all the nice space into those heist posts. And so really we wanted to come up with a new way to represent our polar terrain data and not do a naive thing of just converting it into latitude, longitude, and try and bin those into the tiles. That's just not efficient. So we thought, hey, what if we just used 3D tiles and kind of used a quad tree and 3D tiles and their general purpose bounding volume hierarchy structure to organize data in a way that works for us and how we want to use it. So we've been using 3D tiles in SDK since 2017, I think. It's been a while, and for rendering massive geospatial data sets, I think one unique approach that we take is that we put our 3D tile sets in any coordinate system. So you can have a 3D tile set that's on the Earth, which is kind of what we're all used to, Earth fixed. You can have a 3D tile set that's in the inertial frame. You can put a 3D tile set on an aircraft and have it flying through your scene. And of course, you can also put it in other central bodies, and like the moon or Mars or Ceres. And so one of the challenges is that we had no way to get that lunar data into our tool. And so we ended up having to kind of come up with our own solution where we take raster imagery, raster terrain, we bake those into GLTF tiles, and tile that up in our own 3D tile sets. One of the important things here is that we kind of approached this with polar stereographic projection front and center. And so like here, I'm looking at the pole. You can see that we're not bunched into those same confined tiles, just showing the wireframe to show that things aren't bunched. We got a nice polar cap there on the moon. We had other height references. So because this was written the way it was, we found out, okay, well, we can do this on the Earth too, and do polar data on the Earth. We can do regular terrain data on the Earth. And then as we were developing this, it turns out some customer happened to just reach out user happened to reach out and say, hey, I'm doing stuff on Mars. Can you guys do Mars? And so we said, well, sure, why not? And we added our custom height reference, the Mars GMM3 height reference, which means for those Mars data sets that are referenced from the Mars aeroid, we can easily process that terrain and do interesting things of pulling that geometry into some of our analytical computations there. You see a rover and computing access and getting obstructed by the various terrain profiles that are there on Mars. So none of this would have been possible without the open standards from the Kronos group with GLTF and Cesium with the 3D tiles. And so we're quite grateful to be able to have them as a business partner and working with them to help do awesome things all across the solar system. So that's all. Thank you.